Hello, dear students. Hope you are doing well. In this video session, I will be explaining you about intermolecular forces. Let's go through a few main points in here. First of all, I have given an example of HCl in here, and we know the electronegativity chart from here. We can see that hydrogen is 2.1 and chlorine is 3.0. So the electronegativity difference is 0.9. So we can say this is an covalent bonding. Also, we know that covalent bondings are between non-metal and non-metals. In here, this bonding is inside one HCl molecule, so hydrogen chloride molecule. So we say that this is an intramolecular force or intramolecular attraction. You can remember the word intranet. Intra means private, it's something inside. So intramolecular forces, they are the forces that is inside a molecule. But let's take two HCls now. As we can see, from the electronegativity difference, we know that chlorine is more electronegative, so the electrons are going toward the chlorine. That's why this is negatively charged. And hydrogen, because hydrogen's electrons are going from it to chlorine, it becomes sigma positive. So what will happen between these two, chlorine and another HCl's hydrogen? Because one of them is negative, one of them is positive, we will have an electrostatic attraction. But this time, this attraction is between two different molecules, so between two molecules of HCl. So what we say that this is intermolecular forces. You can remember from ICT lesson, internet means between, intranet means inside, private. Also remember this note that all bondings that we have learned so far, they are between positives and negatives, and they are attraction, because we know that if we have two positive signs or two negative signs, they will repel each other. It's gonna be repulsion. So far, let's do this example of water. We can see that in water molecule, we have this bonding and this bonding. You see they are inside one water molecule, so they are intramolecular forces. Also, we say that they are covalent. Let me write them in here. So they are covalent bonding. Also, inside these water molecules, they are covalent too, but between two water molecules, we have one sigma negative, one sigma positive. So we will have an attraction, which will become intermolecular forces. We are going to learn three different types of intermolecular forces: London dispersion, dipole-dipole, and hydrogen bonding. Let's go through London dispersion forces. Now, first of all, I put an example of helium. Helium has two electrons, so helium is stable, meaning that the helium will not bond intramolecularly with another element because it's already stable. So it cannot have intramolecular forces. So let me even draw that. So they cannot form a shared pair, but they can form intermolecular forces. Let's explain how. First of all, you need to know that the electrons, they always move. So if I write an example of hydrogen, it has one electron in outer shell. Let me draw the shell too. So this electron is always in constant move, so it's always moving. Just keep that in mind. Let's take a look at this helium element. As we know, helium has two electrons, and these electrons are always moving. So let's stop the time at this point. Stop time. So let me write in here. At this point, electrons are in here, and we know that electrons are negatively charged. So the right side of this molecule element, not molecule element, is gonna be negatively charged, sigma negative. So we know that electrons are in here. So this side is electron deficient, meaning that there is no electron, sigma positive. But what will happen after some time? Imagine these electrons will come in here at some point. So what will happen to the signs? The signs will change. This negative will come in here. This positive will come in here. So it's gonna be sigma negative in here, sigma positive in here. So let's say that now we have this helium is coming nearby another helium element. What will happen? We know that this we have electrons in here, and these are electrons too, yes? So these electrons will repel these electrons. So they will come to here. To this one, we say this is induced. Induce means forcing, induce dipole. Please don't forget that. So at this moment, because these electrons are here, they will repel these electrons here. So what will happen at this moment? It's gonna become sigma positive and sigma negative. So one side is sigma positive, another side is sigma negative. What we can say, we have an intermolecular forces. But is this force will gonna stay like that for forever? No. Why? Because these two electrons, they will come in here, and this charge will be plus, so it will break again. Then after some time, it will form again. So it's gonna be bond breakage and bond formation. Bond breakage and bond formation. Let me show you in here. As you can see, the bonds are formed, broke, formed. So you see this, the electron cloud is always changing. So as this is not a permanent, as this is temporary, we say that this bonding is temporary, temporary dipole, temporary dipole, and this one is called induced dipole because it is forced to remove change their location. So it's a temporary dipole. As this is temporary dipole, it's gonna be weak force. Weak force. As it is weak force, it's gonna have low boiling point. Okay, and we call these kind of forces as London dispersion forces. And one more thing, let me move here, move back. Just remember that London dispersion forces are found everywhere. Why they are everywhere? Because as we know, all elements, they have electrons, and as they have electrons, these electrons they are always in constant move. So there is an uh, instantaneous dipole, also induced dipole. So we will have a London dispersion forces. Also, you have to know that because they are weaker, what will happen? They will create a temporary bonds. Because they are weaker, it's gonna be temporary. As this is temporary, mainly they are in gas form. Molecules that have an London dispersion, they are mainly in gas form. Also, it will depend on the molecular mass, which we will come to that. Also, just remember that London dispersion forces, they are between non-polar molecules. Just to remember, the polar molecule is a molecule that should be one or polar bond. One side should be positive, another side should be negative. But if it's a non-polar molecule, it means that we don't have this positive one side, negative one side in the ends. Last thing is that remember, the larger the molecule gets, the more electrons we have, and more electrons means we have stronger London dispersion forces, and it's gonna make it higher boiling point. You see in here, mass is increasing, also electrons increasing, boiling point increases. Also take a look at alkane example. By the way, they are all non-polar. And why they are nonpolar, you can check the electronegative difference is 0.4 between carbon and hydrogen. Let me write in here, H, 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 H. You see, all sides are positive of this molecule. You see, all the sides, all the ends are positive, positive, positive. So this is nonpolar molecule, and in nonpolar, we have only London dispersion forces. As you see, the masses are more. The more the masses means the more the boiling point. It is increasing. Thank you for listening to this video session.